Hi, this is Darren with Brew-Boss, and today I want to introduce a new product to you that we're handling. It's called the RoboBrew. We've got a lot of requests for 120 volt systems in our Brew-Boss website. And as you know, Brew-Boss is the pinnacle of brewing systems. It's a very high-end, completely automated brew step control for home brewing. But we get a lot of people asking for smaller apartment size systems, less expensive systems in the 120 volt range. If you're familiar with the Grainfather, this system is very similar, but about half the price. It's called RoboBrew. It's a very lightweight brewing system. Everything is in this vessel. It's capable of making up to a 5-gallon batch. Depending on the gravity of your beer, it may be a little bit less if you like high gravity beers. Basically consists of the main unit, which has an integrated pump. We only sell the version with the pump. We feel that the recirculation improves the efficiency enough that it's worth the extra cost. There's an integrated pump with a feed tube that ends up coming through this and bringing the work from the bottom of the kettle back to the top. It is a brew-in-a-bag type system, basically just like the Brew-Boss. It's a brew-in-a-basket. There's a false bottom that goes into the bottom of the unit. There's a shell of the filter that holds the grains, and in that shell you insert a very similar to a coffee filter, only it doesn't do the center out forced infusion. This fits into the bottom of the grain bin, grain basket, and there's a sliding tube on here I can show you that allows you to adjust where the level of your top of your grain is. So we'll show you that a little bit later. And then what goes in there on top of that is another filter screen which goes on top of the grain basket, and that's got a little rubber seal on it so that nothing can get out the sides. And then there's a nice little carrying handle that sits in here that allows you to lift the grains out. And once you put this in and do your mashing, it sits on the top. To remove it, you put the handle in, lift up and turn 90 degrees. It allows you to set the grains above the liquid of the wort and then actually do a sparge with some hot water to rinse the grains off to bring it up to your pre-boil volume. Now the system's kind of nice, but what it doesn't do is it doesn't give you the hot water to do the sparge. So you have to do that on the stovetop or with another brewing system, is to actually fill the pot completely before you start brewing and then drain the liquid off. So when you fill up the pot, you fill that to your full boil volume. Okay, so your full volume, as you know, brew-in-a-bag is typically a full volume mash, where you start out with all the water you're going to start with. Well, this system doesn't allow that because there's just not enough space in here to do a full volume mash. So what we're going to do is start out with the amount of liquid that we would normally calculate using Beersmith or another brewing program. Fill it to that amount of water plus a little bit, heat that up to a strike temperature, and then drain it off into a cooler or something that's going to maintain that heat while we're going through the mash process, so we can then take that hot water at the end and pour it over the top of the grains to get to our pre-boil volume. So that's basically the system in a nutshell. What I'm going to do is get started here with a batch. I'm making a porter today that I'm going to put into a bourbon barrel. So I want to get some water in here and I'll check back. Okay, I've got my water source here, and I'm going to fill up the RoboBrew up to about the 8.5 gallon mark, almost as much water as I can get into the kettle. And the reason I'm doing that is, like I said before, is I want to start with all the water that I'm going to need for the entire batch. The problem is I have to drain some of that off. I need some hot water for a sparge, so I'm going to go ahead and heat that up right before I do the mash. Lower the level so that I have room to add the grains so it doesn't overflow when I add the grains. And then I'm going to retain that water in a cooler so that I can pour the hot water back over at the end. So right now I'm just adding water. Like I said, I'm going to fill this up almost to the very top. Normally you wouldn't do that. The instructions, I think, with this tell you to start out with a normal type mash to grist ratio. But I'm going to do more of a brew-in-a-bag in the system like the Brew-Boss system works, and see how it works this time. Okay, as you can see, I'm filling here. I'm almost to the top. I'm going to fill this up till I get just above the word gallons, where you see the gallons stamped into the vessel. And I'm going to go ahead and then start warming this up to my strike temperature. And I found a strike temperature of about 155 degrees is working for my 152 degree mash. We'll see how well that works out today. As you can see, I'm getting very close to where I want to be. You say, normally you don't fill it this high. I'm just going to overfill this a little bit. Okay, there we go. You can see where I've got the water level. And I'm going to go ahead and fire the unit up and set my strike temperature to about 155 degrees. And I'm going to right away turn the heaters on, both heaters. Turn those switches on. There's two actual heater buttons here. One says 1,000 watts, one says 500 watts, so we have a total of 1,500 watts. You kind of have to do your own power management with this system. And then there's also a recirculation pump, which once I get the heaters going, I will set that up so I recirculate during the heat so that I get better heat distribution throughout the kettle. So I'm going to go ahead and turn it on. I'm going to set the temperature to mode to Fahrenheit, and I'm going to change the set point to 155 degrees. Actually, it doesn't allow me to do 155. It only goes in 2-degree increments, so I'm going to use 156 for my strike temperature. Okay, it's automatically turned on, both heating elements here. You can see the display. I've got my set point on there. And both heating elements automatically turned on. There are relays inside the unit that'll select the power that it needs, either 1,500 or 1,500 watts, depending on how far the set point is away from the actual temperature. As you can see, I put pretty warm water in here. My storage tank, I've got a well. That tank ends up getting to room temperature, and it's been pretty warm here. So my water temperature is about 77 degrees. So you can see the current temperature in there is 78 degrees. Actually added a clock here so we can look at how long it takes to do this entire 5-gallon brew session. We started roughly 2 minutes ago. Took me a couple minutes to find a screw to hang the clock. So I'm going to start the recirculation system going now. And the way that works is you install this little arm into the valve that's here. Always make sure this valve is closed when you're doing anything with the pump, especially once the water gets hot, or moving this arm, because you don't want hot water or boiling water spraying all over. It's kind of a little bit of a safety issue, I think, with this device, but as long as you're careful not to do that, you should be okay. So all you do is insert it into here, tighten up this little nut, and you can see there's our recirculation system. I'm going to go ahead and fire up the pump here just to show you what it does. Turn the valve on. And that's basically the flow. So this allows you to adjust the flow during the mash, and we'll get to that when we actually show you how the grain seepage rate is, so that you can adjust this as it's doing the mashing. Right now I'm going to leave it wide open so that I get a good recirculation. I'm going to put the cover on to retain as much heat as I can in the vessel. There are some clamps on here that hold the cover down tightly. And I'm going to go ahead and just add a piece of hose in here that you'd normally use during mashing, just to bring the recirculation more into the center of the liquid. So I'm going to turn the valve back on. And now I'm basically just recirculating the hot water within the vessel as we're going to heat this up to mash temperature. So as I said before, we're trying to hit 156 degrees. We started at exactly 8:25 on my clock here, and we started about 77 degrees, and it's up to 82 degrees right now. So we're just going to let this go. I'll check back when we start getting closer to my strike temperature of 156 degrees. Okay, I'm currently checking in here. I'm at 152 degrees. I had set my strike temperature for 156, but while I was crushing my grains, I was thinking about my grain load here. It's going to be about 10 pounds of grain. I think I'm going to end up cooling that water down below 152, which is my desired mash temperature for this batch. So I'm going to up my strike temperature to 158 degrees for my strike temperature now. And you can see we're a little over an hour into this, and we're still not up to 156, even what we were originally looking at. And we started out with pretty warm water here. So it's not incredibly fast. You can see you got both heating elements are still on, and we'll wait till it gets to 158 here, and when it does, we'll add our grains. I'll check back then. Okay, we just hit 158. You can see it's automatically turned off, the heating elements. The lights are no longer on, and the time is about 1 hour and 6 minutes. to get a full kettle of 77 degree tap water up to 158 degrees. So now what I'm going to do is drain some of the water off. We've just reached our strike temperature as I've shown you, and I'm going to go ahead and drain some of the water off now. And what I find the best way to do that is just to turn the pump off. And I've just got a bucket here, and what I'm going to do is put this bucket into a cooler to keep it hot as when it came in, as hot as I can. So what I do is I typically just remove the cover, because I'm going to need to do that to put the grains in. I pull this hose off that I had on here, place that into the bucket. This works out really nice. Rotate this around, and once I get the cover off, I just basically bring the water level down to what my mash volume should be by turning the pump on. As you can see, I'm getting a flow of the 158 degree water into my bucket. Just about down here, about 2 gallons of water. I'm going to go down to about the 5 3/4 gallon mark, to where I'm going to start looking at my grains and see if I can get them all in. If I find out that the water comes too high, I can always drain some additional off as I'm adding the grains. So just about to a little bit below the 6 gallon mark, I'm going to shut the pump off. So I've taken out a little over 2 gallons of water. Shut the valve. Now you will get some siphoning effect out of here, which is what you're going to use that valve for. So I'm going to set my hot water aside in a cooler. That should stay fairly hot during our mash cycle. Now what I'm going to do is add the grain basket. And I'm going to set that in here. I've already got, I should show you, I've got the false bottom in, and I've got the tube extended as far as it'll go without sliding off. I'm going to drop the grain basket in. Then there's a small rubber plug, it's a cap, and I've got a picture of that on the video here, that goes over the top of that tube while you're adding the grains to keep any grains from going down that center tube. So just place that on loosely. And I've got my grains here, and I'm going to just slowly add those into the basket. And what I typically do is I add about 2 or 3 pounds at a time, and I give it a stir, just to make sure I don't get any dough balling. We'll do that again. Okay, I've got them all good and stirred and all submerged. Now I'm going to remove the little rubber plug from the top, and I'm going to add the top cover. Okay, you put the cover on and basically push it down until it hits your grain bed. Set the level of this tube just above where you're at. And then there's this fitting here. You want to put this fitting with the cone up on top of that tube. So I've got that little fitting placed on top of that tube, and you basically bring it down flush with the top. And that becomes the over drain. Now what I'm going to do is place the tube for the recirculation onto the top of the grain bed and attach it, and I'm going to start the pump. And note the time. We're going to mash for an hour, so we'll go until it's 10:40 on this clock. Open the valve. And you'll see we have a flow coming through now of our mash. It's flowing through the grain bed, and we should see this start to rise up to the level of the overflow drain. And when it gets to the level of the overflow drain, any excess will automatically flow back to the bottom of the kettle to keep you from starving the bottom. So now what I'm going to do is add the cover to this so we can maintain our temperatures a little bit, and I'll show you that in a wider view. Okay, now that we've started our mash, I'm just quickly going to turn off the valve so that I can add the cover. And how I add the cover is just to pull the silicone tube off, run it through the hole, cover onto the kettle, and reattach the tube and open the valve. So now I'm getting my recirculation going on inside, and I've got my cover helping me maintain the heat. Okay, I wanted to show you here what happens when the grain bed is properly set. You can see that it's siphoning through the top overflow tube. And you see I'm getting a little too much flow. It's well above that little churn, but I'm getting a whirlpool going from the hose that I've got in there. So it's kind of whirlpooling through the grains. And what I'm going to do is restrict the flow a little bit on the pump by using the flow valve on the side to try to get a better flow rate. I think we've got too much recirculation occurring. So I'm going to turn this a little bit. And as you'll see, the flow rate's coming down a little bit. I might even go a little bit more. Yeah, and that looks better. It's just barely coming over the top. So I'm going to replace the cover, and we are going to mash this for an hour. And okay, I'm back. We're in the middle of the mash. We've got about a half hour left exactly. You can see the temperature. I've got it set to 152 on the RoboBrew. Is currently at 50, and it's turned on the 500 watt element, not the 1000. So when it's really close to set point, it only uses the 500 watt element. When it's a long way away, it uses both. It doesn't hold temperature perfectly. I've noticed it go down to 148, up to 154. So it's going back and forth, but it's not bad. It's all within the range. You can see I'm starting to get some color in my hose here. It's a porter, so it's pretty dark. And you can kind of see inside there what's going on. I got a little bit of the drain going. I got it regulated down with my valve, so I've got the right flow rate. Overall, it's quiet. It's doing a pretty good job. And like I say, I've got about a half hour left in the mash. During this time, I'm getting my chiller ready. Now, the unit does come with a chiller. You can see I've got it here. I haven't ever used it. That actually comes with the RoboBrew setup, and it fits nicely inside. You just put, cold water in one side, your drain on the other, and you can do a pretty good job of chilling what's in there when we're done. But I've already got our accelerator that I use exclusively. I find it much faster and more efficient than immersion chillers. So I'm going to use this today, and it's kind of I'm using it with the RoboBrew. I wanted to kind of show you what I've got set up here. Now, once this is done with its boil, I'm actually going to use the pump arm here, and I'm going to connect a hose. I've got that hose right here with a cam lock. I'm going to connect it to the input of my accelerator with a cam lock. So this goes on here like this. And the other end, let me just lock that on. The other end is going to go up onto the tube. I'll flip that around actually and bring it over to the, out to this side. And I'm going to pump it through the accelerator. On the back end of the accelerator, I've got a valve. That's what I use to adjust my output temperature by restricting the flow through the accelerator. Then goes to another cam lock, and I've got a piece of tubing here that'll eventually go into the fermenter. While it's about 5 minutes left in the boil, I start this flow going through, so I actually sanitize the inside of my accelerator with boiling wort. So by pumping the boiling wort through it without any water flow, I do a good job for 5 minutes of making sure there's no bacteria inside my chiller. Then, after I'm done with the actual brew session and the boil's over, I'm going to just take this output hose and I am going to start the cold water flow, keep the pump on, and start regulating the flow using this valve to get down to my pitching temperature, which I'm hoping to get to about 68 to 70 degrees to pitch my yeast. So once I get to that temperature, I keep the valve in the same position. I shut the pump off using the pump switch on the RoboBrew, and then I use the hose that's on the discharge right here, and I'll put that into my fermenter. So you'll see that later on, but what I'm doing is I've just pre-set up my system to be ready for that chilling process with the hoses that I'm going to need and the fittings that I'm going to need. Okay, we've finished our 1 hour mash, as you can see by the clock, and I'm going to up the temperature here to 168 degrees. Okay, we're at 168 for a set point now. Once a few seconds goes by, you'll see the lights turn on to try to raise that temperature. Okay, it used the full 1500 watts automatically. You could see it flip them on. And so what I'm going to do now is we're having a 10-minute mash out once we reach 168 degrees. So it's important to watch this step and see when we hit that set point. Once we set that, we'll start a timer for 10 minutes. And after that 10 minutes, we'll be done and ready to remove the grains. Okay, we're just about to reach 168 degrees here. As you can see, time is now 10:45. Once we hit 168, I'm going to start a timer. And we'll do 10 minutes of mash out. You can see the temperature starting to drop a little bit actually. When we start getting up on these higher temperatures, I notice that the automatic selection of the heat is a little bit behind. So we're still at 500 watts, it's 3 degrees down. We haven't hit 168 yet, so I will check back when we do that. Okay, as you can see, it's at 165 yet. It's been holding this temperature for several minutes. It seems at 500 watts. The unit struggles to be able to get up into this kind of a temperature range with a 120 volt system. That's understandable. So what I do is I think I'm going to change the set point up to a much higher temperature, and once it hits 168, turn it back to 168 in order to force this unit to step up the power setting, and I think it's going to do it any second here. Okay, you'll see now that it's going with 1500 watts. And what I might do here is actually turn off the 500 watt element. It appears that 500 watts isn't enough up at this temperature range to try to get it. So I'm going to watch this carefully until it gets up to 168. As soon as it hits 168, I am going to set the set point to 168 and start a timer for 10 minutes. Okay, I've just hit 168 degrees, so what I'm going to do is automatically just change this back to 168. So it'll hold that and turn on the 500 watt element again, and we should see both elements go off, and they did. So hopefully this thing will be able to hold 168 now with just the 500 watt element, because that's what it's going to try to do. And we've got a 10-minute timer I'm going to set now, which means right at 11 o'clock I will be completed. You see we have a little bit of overshoot here because those hot plates on the bottom probably retain some heat. So we'll let it sit here for 10 minutes, and then we'll remove the grains. Okay, we're at the end of our mash out, so I'm going to turn the pump off, and we're going to go ahead and remove the grist here. So the way I'm going to do that is remove the hose that I had inside, put that into my bucket, remove the cover, set that aside, locate the handle, turn the hose ahead. And now this is very, very heavy actually. Okay, and we let that drain. Okay, so I've got the grains draining on top of the kettle. What I'm going to do right away is I'm going to bump the temperature up as it's draining to bring this to a boil. So I'm going to bring it up to about 220 degrees because I don't know what boil is going to be. So what it will boil at, that temperature is unknown. So we're just going to bump the temperature up to 220, and it'll go to full power, which it has, and it'll start bringing this up to a boil while we're doing our drain. So we'll save a little time there. What I'm going to do now is put some of my sparge water over the top of the grains that I stored in my cooler. And again, I've got the temperature set to 220 right now, so that we're starting to bring the kettle up to a boil. And I just add this a little at a time because we don't want to overfill. Okay, I'm checking in here. I'm currently at 185 degrees. I'm trying to get up to a boil. And a couple things I've learned here while working with this is it's very hard to see the level inside without actually lifting the strainer out. So a sight glass or something would be really nice on this unit. Maybe something you'd want to add as an add to it once you get it, because you just can't see how much is in there, and it's pretty heavy to lift those wet grains up to take a look. So my recipe says that I should have a 7-gallon starting pre-boil volume, and I was up about 6.5 by adding the hot water back in that I had. So I had a little more grain absorption than I calculated with the Beersmith. So what I've done is taken some hot water and poured it in here, and I'm letting it drain to try to get to the 7-gallon pre-boil volume that I'm looking for. The other thing I learned on this is this table way too high. To be able to work in here and look in here, I had to put a half barrel down here to stand on, to look in there and to do my pouring. When you're filling it and doing your sparge water, you want to make sure you never get above that drain tube that you have in there, or else it'll just go right into the bottom of the, right into the wort without going through the grains. So you want to make sure you pour it in gradually. So I learned that. So next time I do this, I would definitely shorten this table, probably by a good 12 to 14 inches, so that I could see in the inside of here and be able to lift a lot easier, because it's very heavy when it's full of liquid and grain to remove it initially. So it's just something I learned going through this. Other than that, it's been working fairly well. We're up to 186 now, so we'll see how long it takes to get to a boil here, and I'll check in then when I'm close to that. Okay, I'm not seeing any dripping anymore, so I'm going to go ahead and remove the grain basket and put it into a catch container, so if you catch anything that might drip out after. So you can see, this is the part where I said it would be nice to have this lower, because I've got to get on a half barrel here to try to get this out. You can see there's not much dripping going on anymore. I'm going to move that into this container to catch what's remaining. And then I'm going to place the cover back on the container, because that'll help retain some of the heat that's inside here. We've only got 1500 watts of heating power, so with 110 volts, we really need to maintain as much heat as we can. And I think I might just leave this on for the entire boil, actually, because there is a sizable, about 1.25 inch, 1.5 inch hole in the glass that'll let any steam and DMS get out as long as we're boiling. But I think that'll help keep the vapor pressure up a little bit inside here, so that we get a better boil. So we'll see what happens when we get there, but I put this cover on. I'm going to leave that on until it gets to a boil. I think that'll retain some more heat. Okay, we're at 203 degrees right now. We're still at full power. And this is where I start to get concerned about hot break. As you can see, I've got some hot break starting in there, if you look through the hole inside. And I'm going to be keeping an eye on that. And should I start getting any hot break where it starts rising up towards the point of bubbling over, my solution is just going to be to shut both heaters off, very similar to what we do on the Brew-Boss. Just turn the power off, let it settle, and once it settles, put the power on full again. And usually it only takes 1 or 2 cycles of that to handle the hot break. So we'll see if I'm going to get one heating it up this slowly. You can see the time right now is about 11:45, and we're only at 203 degrees. Okay, I'm checking in here. I'm just starting to get a hot break here. This usually happens about 202 degrees for me, and I'm just getting this now. And I see that the temperature in says 214. There's absolutely no way that that temperature is accurate then. Now what I'm believing here is the temperature probe actually sticks through the bottom of the kettle. Right next to, or right through the heating plate. There's some built-in heating elements right in the base of this. And as you can see, I'm getting a hot break now, and this usually happens to me way before 214. I never even get to 214. So as you can see, I'm getting a dangerous here. So I'm turning the power off manually to the switches. I just turned the power off to both switches, and we should see this come down in some time. Yep, there we go. And as soon as it drops all the way to the wort level, I'm going to kick it back on again. I found with the Brew-Boss systems that if we just take the power down to 0 momentarily until it settles, and bring it back up, we can get through hot break without any incidents. So we're down. I can see this. I'm going to turn the power back on to both elements. See, all I did is click the switches on, and we'll see if we get another hot break. And temperature is still reading 214 on here, so you can see it's starting to break through. And we're getting to a boil. I'm believing that the temperature is off by about 5 degrees because of the being through the hot plate itself. And we'll see if we get another hot break here. Usually 1 or 2 times is all that's needed with the reducing power. And it looks like I'm building up another hot break, but it's not so bad. We do have a boil going though, although it's not a furvious boil like I'm used to. Okay, so at this point I'm gonna go get my hops filter spider, and put that in. And I'll be Well, actually, we're getting another hot break here, so let's hang on. With only 1500 watts, it's taking a little longer to go through the... I'm going to drop the power again, let it settle. You can see once that bottom plate cools off how quickly with electric the controls occur. See, now that I broke through again, I'm going to turn the power back on. We'll see if we get a third hot break. This would be very rare. Power's back on. You can kind of see the boil we're going to get out of this 1500 watts with this much of a volume. I'm hoping I do get my gallon per hour boil off. I may have to boil a little bit longer to get down to my 6 gallons that I'm looking for my net amount. Okay, I think we're through hot break. I'm going to go get the hop spider and put that in. Okay, you can see my hops were just added into the filter spider, and this is the boil that I'm getting. This is about the biggest batch you can do in here. I'm looking, it's about 7 gallons right now. I'm looking for a net of 6, so I'm hoping for a boil off in an hour. So I'm starting right at about 12 o'clock here. So I'm going to finish my boil tentatively about 1. And 40 minutes from now, or actually 50 minutes from now, 10 to 1, I need to add my second set of hops. So you can see I've added the filter spider in here. Okay, as you can see here, I've added the hops, and I took the cover off. Even though I can set it on top of here, I noticed I was getting a lot of condensation on the cover, and it was dropping back into the wort, so it was reducing my boil off rate. You can see the steam that builds up so quickly, and not enough is getting out that little hole. So I'm now running it without the cover, which did reduce the bubbling rate a little bit. And I'm going to show you inside here. You can see what the boil looks like. It's not a real raging boil, but it'll work. It looks like I might have to increase my boil to 90 minutes to compensate so that I get my proper final volume. Oh, okay, just an update. I'm coming up on when I'm supposed to add my second set of hops before the end of the boil. I like to put that in about 20 to 10 minutes before the end of boil. And as you can't see, but I can see, we're only at 7 gallons here. I've hardly lost any wort at all. I started out at 7.2 about, and now I'm right at 7. And I'm just not getting the boil off I get with a typical brew setup. But all that means is I need to boil a little longer, so I'm going to go to a 90-minute boil. And with a 90-minute boil, I'll boil some more off, and just 10 minutes before the end of that, I'm going to throw in my final hops. A little adjustment here on the fly, but I want to get down to 6 gallons, ideally, into my fermenter. Okay, I got about 5 minutes left in my boil. Ends up I'm going to be boiling about 110 minutes here. Hour and a half would have been at 130, so we're going to be about 110 minutes total in order to get my volume down to my batch volume. I'm still at about 6 1/4 gallons, so I'm not quite down to 6 yet. Boil off rate isn't near what it is with a typical brewing system, but you have to just account for that and everything will be fine. So I'm going to go in a little bit heavy here, so my OG might be a little bit lower than I would have liked, but I'm going to go ahead and start sanitizing my chiller now. Okay, so I've only got a couple minutes left in my boil right now. I've added my Werflock tablet. I've added my final hops about 5 minutes ago. I got about 4 or 5 minutes left in my boil. I put a tube on here to the input of my chiller. It comes back out the chiller and recirculates using the pump on the RoboBrew. So I'm recirculating boiling wort through my chiller, and I can feel it getting very hot now. You can see some flow through here to sanitize the inside of my chiller before I actually start chilling. I'm going to start adding the cold water to this and cooling it down, adjusting the temperature on my chiller to my wort pitching temperature, my yeast pitching temperature. Once I get that, I'll take this tube out and then go transfer it right into my fermenter. Okay, I'm all done with my boil. I've timed out. I've been running about 5 minutes and boiling wort through my chiller, and now I'm going to actually start chilling down the contents of the RoboBrew kettle. So I'm going to manually turn the system, the heater elements off right now, rather than change the heat settings or anything. It just makes it easier that way. And I'm going to turn the pump on, it's still on. And I'm going to start the flow of cold water through my chiller. Okay, so I don't know if you can hear that. I've got cold water flowing through my chiller now. This is going to my drain, so I'm coming in the bottom with the cold water. The hot water is coming out to the drain on the top. And it's the opposite for my work out. I'm using the pump on the RoboBrew to pump it into the chiller on the top, and it comes out the bottom. And on my gauge here, I'm already losing a considerable amount of temperature. I went from about 208 all the way down to 160 in about 3 or 4 seconds. So as that 160 degree water comes back around, it's being introduced back into the kettle. And as it's cooling, we'll rapidly lower the temperature of the kettle down to about 140 degrees. Okay, so I'm in the middle, you can see here, of doing a chill, preliminary chill in the kettle. I'm returning it back to the kettle. I'm down to 192 degrees now. I've got the output of my pump on the RoboBrew going into the input of my accelerator. I've got cold water coming in from the tap into the bottom of the chiller, and hot water exiting at the top. And the cool wort is exiting here at the bottom, going through the thermometer. As you can see right now, I've got an 82 degree temperature going back into my wort in the kettle. And that's beneath the surface there, so I don't get any hot side aeration. So before I start playing a lot with this, I like to get the temperature down a little bit. And you can see I'm down to 80. In order to get this a little bit lower, I can restrict the flow on this valve for how fast it's coming out. Okay, and that'll end up slowing the amount of time that the wort spends in the chiller will increase because I've lowered the rate, which means it'll get colder on its way through, ultimately getting down to as low as my temperature of my tap water. So I'm trying to get down to about 70 degrees. For a good pitching temperature. It's summer right here now. My groundwater is a little bit warmer than normal, so we'll see what I can get out of this. But I'm trying, by restricting the flow out of the chiller, we can set our temperature. And once you make an adjustment, you need to wait 10-15 seconds for the adjustment to take hold. So I'm going to do this until I get down to about 70 degrees. Once I get to 70 degrees, I'm going to take the tube that's returning. I'm going to shut the pump off, and I'm going to move it into my sanitized fermenter, which is ready for my wort. So you can see the temperature is down a little now. I'm down to 78. I might restrict it a little bit more. Make sure this valve is wide open so I'm getting maximum flow out of the pump for pressure head. And I'm going to try restricting it a little bit more. Now the temperature in the pot, in the kettle, it's about 167. As you can see, that's going down too because I'm returning about 77 degree water or wort into the kettle. And as that's going in, it's changing the temperature of what's coming back into the accelerator. So I get an accelerated chill by doing this, by lowering as quick as possible the temperature in the kettle itself. Another good step to do this is to bring this down to about 140 degrees so that if you want to do a whirlpool or something else, I didn't have many hops in here, plus I used a hop spider, so I'm really not going to need a whirlpool. But if you were doing that, you would want to bring this down to about 140, then do your whirlpool. But things are going pretty well here. I'm down to about 72 degrees coming out of the chiller, which is excellent. And make one adjustment here. If I can get that down to about 70, I'm ready to move this over to my fermenter. As you can see, I'm right above 70, so I feel good about that. I'll get take the cover off my fermenter. Okay, that's all sanitized. I'm going to turn the pump off. And with the pump off, I can then remove the hose, the return hose, transfer it to my fermenter. Okay, and then I'm going to turn the pump back on. Sorry, I'm using my hand for the camera. So the temperature of my wort coming out is right now at 70 degrees, as you can see here. And that's where I want to pitch my yeast at. It's about 80 degrees in the building right now where I'm at. So this is the flow that I need based on my groundwater, which is pretty warm today, but at least I'm able to get it down to 70. And I'm putting it into the fermenter so that I create some foam and some oxygenation. Okay, as you can see, I'm transferring the wort into my fermenter now. What I'll often do is take the hose here and hold it up high above the fermenter to try to create some bubbles in there so I can oxygenate the wort a little bit. You see, by holding it high, you get some really good bubbling in there. If you do this for about a minute or 2 minutes, that's all you really need. And this is also a good time to take a sample. Now, if you got a little glass or something, put it in there. It's nice and cold already. It's 70 degrees. And take your sample so that you can measure your original gravity. This is time I typically do that, and that's what I'll do now. So anyway, I just took a sample, and my original gravity is 1.057. Calculated on my recipe, if you see here, was supposed to be at 1.059. So I missed it by a little bit, but my volume's also a little bit higher. I'll find out for sure with my fast ferment here because it's marked on the side. I don't know if you can see that with volume markings. To see, I think I'm going to be a little over on my volume. So that might account for some of that, as well as because I didn't do a full boil down to 6 gallons. I was a little bit higher than that. So I think we came in the realm here, and I used a mash efficiency or a brew house efficiency of 72%. Is my estimate for this. So I think I pretty much nailed that for all practical purposes, which isn't bad for a single vessel brewing system. Actually, right now I'm pretty much done. Once the fermenter is completely full, I'm going to be adding my yeast and putting it in my temperature controlled fermentation room. And thanks for watching.